Welcome to the Data Logger version 1.3, the first of two short videos demonstrating how the Data Logger functions. The Data Logger is a useful tool that has been developed to replace the need for several large, heavy and expensive test tools. For example, spectrum analyzers, chart recorders, UPSs, transformers and extension leads. It also removes the need for all these items having to be calibrated at even more expense. As well as being able to replace all the above test tools, the Data Logger is also small enough to be carried and used by one person, thus eliminating the need for various staff. The Data Logger is also set up to allow a tester to commence the gathering of data much faster than using traditional methods, as the Data Logger settings are all pre-arranged defaults. The Data Logger is approximately the size of a shoebox, with a harness protruding from it that has parasitic connections which connect to the front of the VOBC. A laptop is then connected to the Data Logger box via an RJ45 cable. This allows the user to graphically view and log the data. All items are powered by batteries, therefore eliminating the use of transformers and extension leads on the train. The data itself is automatically logged as a CSV file onto the laptop's SD card. A Data Logger viewer program has also been created to allow the user to almost instantly view and analyze results. The use of chart paper has been eliminated as all data is stored electronically and therefore is available to be viewed using several other programs like Excel, Word, etc. Now looking at the Data Logger version 1.3, we can see a graphical representation of the several signals that we've are monitoring using the software. We have bullet buttons which allow us to select the signals individually. At the moment you can see the signals are all flatlined due to the fact that we're not actually connected to the VOBC or a controller. Below that we've got a window called the annotations window, which allows the user to add comments while testing. These comments are then appended to the actual data that's been recorded into where the CSV file is burnt. Below that we've got the CPU1 and CPU2 variables, 32 variables each. So all this data that we can see here gets burnt onto the SD card, and it's burnt into a CSV file, which is the date and timestamp file, as you can see over there. Above that we've got a switch that can turn the Data Logger on and off manually, though when the software starts it is automatically defaulted to turn on. To the right of that we've got the new log file button, which allows the user to click that button and that automatically will create a new file with a new date and timestamp, thus eliminating the laborious method of having to stop the software, create a new file and start it up again. Above and to the right we have the y-axis shift. This allows the user to shift any of these signals up and down, and this only affects the signals that the user can see graphically. It doesn't affect the actual data that gets burnt to the SD card. Okay, so that's pretty much it. There's a few additional features which we'll hopefully see in the Data Logger viewer software. The next tab is System Settings. Most of these settings have been defaulted to function correctly. It's very unlikely the user will be dealing with any of these settings, but they're made available in case. Okay, so we'll end this part and we'll hopefully see you in part 2. Thanks.